Today we're going to go over spheres. So we haven't gone over spheres yet. So we're going to do both the surface area and the volume today for a sphere. So you can think of the surface area of a sphere as the total area of all of the non-overlapping strips it would take to cover the sphere. Okay, so think about, I don't know, a balloon, and you were to take, I don't remember what this is called. You were to take newspaper strips and like stick them on the balloon. Yeah, that. Around the outside, that is your surface area of a sphere. Okay? No. Okay, so think about that as your surface area of that sphere. So if R is the radius of the sphere, then the area of a great circle of a sphere is pi r squared. Okay, so the great circle they're talking about is the biggest circle that you can make within your sphere. It goes through that center. Okay, so this is the great circle. Okay, so you're using that great circle around your sphere. Now the total surface area of the sphere is 4 times the area of a great circle. Okay, so our great circle's area is pi r squared. So our surface area is 4 times that. So we get 4 pi r squared as our surface area.
Wow.
So to find surface area of a sphere, okay, it has one basic measurement, and that is the length of its radius. So all you need to find the surface area of a sphere is the radius of that sphere. Okay, same thing with volume. Okay, the volume of a sphere, you only need the radius. Okay, the volume of a sphere is 4/3 pi r cubed. Okay, not r squared. R is now cubed because we are finding volume. So we are going to use both of those formulas below to figure out the surface area and the volume of each of these examples. So in number 1, we want to find the surface area and the volume of that sphere. So I'm going to find the surface area first. Okay, so we're going to find the surface area first. So what do I need to find the surface area? What part of this sphere?
Radius.
The radius. Okay, in this sphere the radius is 5 feet. Okay, so to find the surface area, our formula is 4 pi r squared. So I just need to plug in 5 for r. So we have 4 pi times 5 squared. Now 5 squared is 25. 25 times 4 is 100. So if you want to leave pi in your answer would be 100 pi. Okay?
But you don't have to leave it.
But multiply, you can multiply, yes. And you should get about 314, I'll do 1/6. Yep. You can do 2, that's fine. Okay, so that would be the surface area of this sphere. So now, I'm going to separate this. We also have to find the volume of this sphere. Okay, so below I'm going to find the volume using the volume formula. Okay, so our volume is 4/3 pi r cubed. So again, I just need to plug in the radius. So we have 4/3 times pi times 5 cubed. Now, if you forgot how to enter that,
I sure did. You don't have to show me.
okay, so here what I would do first is cube 5. Okay, I'm going to follow order of operations here. I'm going to cube 5. So I need to enter 5. Okay, I'm going to press this caret key. Yep, it's called the caret key.
Yeah, I'll show you carrot.
Okay, raise it to the third power. Okay, I'm going to press equals. You get 125, so that is 5 cubed. I know it's hard to see. I'm going to then multiply by 4 and multiply by pi.
Whoa. 4
Times 4 times pi
times
equals.
and then you divide by
And then divide it by 3.
Man, I thought that was going to be way more difficult than what it was.
Yeah.
Oh, whoa. Get exotic.
I'm cheating.
Okay, so again, typing this into your calculator. Okay, so I'm going to start with the 5. So we have 5. We're going to push the caret key to raise it to a power. Okay, it's to the third power, so I'm going to type in 3. Press equals to get 125. Then I'm going to multiply that number by this 4 and that pi next to it. Okay, so multiply by 4, multiply by pi. Press equals, and then I can divide that number by 3.
Dude, this is easy. I got this.
Okay, so our final answer here for volume would be 523.6.
So you do soup, carrot cube 3.
Okay, so 523.6 feet cubed. Questions on our first example? Radius.
I'm good. Guess you divide that by 2.
All right, so then we're going to look at number 2. Okay, so again, we need to find surface area and volume. So first, we're going to find the surface area. Now, I want you to think about this. If I take that paper mache balloon, take out the balloon, right, and I try and cut it in half, what's going to happen to it? Well, you'd have what? You'd have a bowl shape, right?
Yeah.
You wouldn't have anything on top?
Nope.
Right. So if I'm trying to find the surface area of this entire shape, I need to use my surface area formula. Divide it by 2, right? But I just said you'd get a bowl shape, correct? What about that top part that's part of this half sphere?
You just do the area of the circle.
Yes.
I think I did that.
So thinking about that bowl shape that's created, right? You don't have a top to it, but in this picture we do. That top part is just a circle. Okay, it's just a circle. So after we find this surface area of this sphere and divide it by 2, I have to add on just one area of the circle. Okay, so I'm going to write that out. So we would have our surface area as our 4 pi r squared, right? That's our surface area of a sphere. We have to divide that by 2 because we have a half sphere. Okay, so dividing by 2. Okay, this is because we're taking half of that sphere. Now, if I were to just take half of a sphere, the surface area, I'd end up with a bowl shape. I wouldn't have that top circle on there. I wouldn't have the lid, right? So I have to add on one circle. Okay, it's the great circle as pi r squared.
That's a lot.
You just have to think about it, right? You take your paper mache balloon, you cut it in half, you get a bowl. This picture isn't a bowl. It's not caved in, right? We need to add a lid on top of it. That lid is just a circle. Okay, so I have to add on the area of a circle.
Keep your food fresh. Don't get rotten.
Okay, so now that I have my formula here, all I need is the radius still. So I can plug in 6 for each r value. So we have 4 pi times 6 squared over 2 plus pi times 6 squared. And again, this is the added circle.
239.
Okay, so that's that added circle on top.
Easy.
Okay, so for our surface area, we should get 339.3 inches squared. Yes. Okay, make sure you can enter that into your calculator.
This is about to be easy, bro. Alright, so you do. What's 2 and 1/4 divided by 2?
Good? All right, then we also want to find the volume of this half sphere. Now, since volume is the space enclosed within your figure, all we have to do to our formula is divide it by 2. Okay, since volume is already that enclosed space. So using our volume formula, which is 4/3 pi r cubed, we're going to just divide that answer by 2 to get the half sphere. Okay, and our radius is still the same. Our radius is still the same. It is still 6. So we have 4/3 pi times 6 cubed, and we'll divide that answer by 2. Okay, so make sure you can enter that into your calculator. So you should get an answer of 452.39 inches cubed.
Got 452.4 actually.
Uh-huh.
I like rounding to 100, so it's like, makes me feel better about
All right, questions on these two problems here, finding surface area or volume of that sphere. All right, then on the back. Number 3, a billiard ball set consists of 16 spheres, each 2 1/4 inches in diameter. So I'm going to change that 2 1/4 to a decimal. That is 2.25 inches in diameter. So what is the total volume of a complete set of billiard balls? Do you know what a billiard set is?
Pool.
Pool.
If you don't know that, you
It's pool. Pool balls. Okay. Because it's called billiards. It's called billiards. That's the actual name of it. So, what we're going to do is find the volume of 1. Okay, we're going to find the volume of 1 of these pool balls. So, since our diameter is 2.25, and to find the volume of a sphere, we need the radius, right?
1.125.
We need to divide that by 2 to get 1.125. Okay, so now I want to find the volume of 1 of these spheres. So volume of 1. That's what that is, volume of 1 of the balls.
5.9.
So I have 4 pi times our radius is 1.125 cubed. divided by 3.
36 inches. Yeah.
All right, so one of our billiard balls is 5.97 inches cubed. So if I have a total set of 16, how do I find the volume of the total set? Times it by 16. So our total volume is going to be 95.52 inches cubed.
The right thing to say after someone says thank you.
I'm tapping to the next level.
Okay. Questions on number 3.
What's the volume of all these balls? 95.52 inches cubed. Someone actually knows that.
All right, so last one here, number 5. Marcus builds a sphere inside of a cube. The sphere fits snugly inside the cube so that the sphere touches the cube at one point on each side. The side length of the cube is 2 inches. Okay, so since this is a cube, what do you know about all the sides? They're all the same. Now, if your sphere fits snugly inside there, what is the diameter then? 2.
Wow. Cuddly and snuggly.
So it's going to be 3.1215.
All right, so now looking at letter A. What is the surface area of the cube? Surface area. It is P times H plus 2B. You need to find P, H, and B. This is the surface area, not the volume. Okay? So to find P, that's the perimeter of the base. Okay, perimeter of your base. Your base is going to be this bottom square here. So 2 plus 2 plus 2 plus 2. 8. Shh. We're paying attention, please. The height is 2. And this capital B value is the area of that base. Okay, that's the one I shaded here. What's the area of that base? 4. Okay, so now I can find the surface area using this formula here. So we have P times H plus 2B. That's 24 inches squared. Okay, so that's the surface area of the cube. Letter B. We want to find the surface area of the sphere.
Oh my
Okay.
gosh, I know how to do
That is the equation on the front. Surface area of a sphere is 4 pi r squared. So if my diameter is 2 inches, what is my radius? Quiet, please. Thank you. So I know my radius. I can plug this into the surface area formula. So we have 4 pi times 1 squared. And our surface area is going to be 12.57 inches squared. Surface area squared, volumes cubed. All right. Last problem. Quiet, please. Last problem. What is the volume of the space outside the sphere but inside the cube? Okay, so they're talking about that white space. Okay? Volume. Those were both surface areas. So volume. So that means we want to subtract the volume of the sphere from the volume of the cube. Okay, so we need to take volume of the cube minus volume of the sphere. Okay, to find the volume of a cube, that is capital B times H. Volume of a sphere is 4 pi r cubed divided by 3. Now, when we did letter A, we found B and H for the cube already. Okay, so B was 4, H was 2. Okay, so we have B is 4, H is 2. In letter B, we found the radius of the sphere. So we have 4 pi times 1 cubed. Stop. Divided by 3. Okay, so 4 times 2 is 8. Okay, here we have 4 pi divided by 3. That is 4.19. Okay, so the volume that's outside the sphere but inside the cube is going to be 3.81 inches cubed.
Done.